Hi there, I'm Dawn Kelly, and for this hackathon, I built PreFilght, a pre-audit smart contract screening tool for Solidity. Crypto lost an estimated $1.42 billion due to smart contract exploits in 2024, siphoning away both capital and public trust. Good news is some related folks have been focused on smart contract security in the last couple of years, and we learn more about vulnerabilities all the time. Now we have a robust smart contract auditing discipline where security experts screen contracts for exploits and help fix vulnerabilities before the contracts are deployed and any real-world funds are at risk. End users now expect those contracts to be audited prior to deployment, and they're a lot less comfortable using ones that happen. The problem is there are only about 20 to 30,000 smart contract developers in the world, and it's an even smaller group of folks that have the skill set to do these kind of audits and successfully find these vulnerabilities. So if you need a smart contract audit, you're going to wait, and possibly for weeks or months. But what if there was an easy way to make the most of your time while you're waiting for your professional audit? And what if you could be confident that you caught common bugs so the code is as clean as possible before you send it to the auditor? So I built PreFilght to screen Solidity contracts for vulnerabilities and generate a report of the findings. It will help Solidity developers pre-screen contract code before they send it out for their professional audit, which will let auditors focus on novel or complex threats rather than reporting on low-level known vulnerabilities, which will increase auditor bandwidth and reduce audit latency. I did create a training data set. I performed a local baseline eval of the GPT OSS 20B using Olama. It was pretty slow, but I did get it to go. I came out with about a 50-50 chance of success from the baseline. I went to train and discovered my M1 was not going to do the job, so I had to settle for validating the pipeline. I used a smaller through Hugging Face, and you get all the details of that here on the slide and in my repo. But I did end up seeing a 39% decrease in validation perplexity. I'm going to go ahead and hit start here because this one can take a little while to run. I'm just going to keep talking while it does that. I would hope to see similar progress in the model if I were able to actually train it. The demo app is coming up here. The effectiveness of training was evaluated on a held out validation split using a teacher forcing technique. That was my first time doing that, so that was really interesting. I'd love to get a bigger computer where I could train the model and see how it works out. I'd also love to be able to partner with some Ethereum Foundation or an auditor to beef this up, make it more robust, and make it available to the community and keep it maintained. I wanted to show you guys here. Here's our summary report, so you can see that you did get a report here that tells you the findings that are issues on your contract. So this is great for folks that are trying to do that kind of thing.